This video is a math walkthrough on how to calculate the volume of concrete needed for a circular silo. Corresponds with level 3 training for carpentry apprenticeship under the G-line section G3 on calculating different shapes of volume. So we'll begin by going through the measurements we're given, and then we'll go through the list of all the things we're trying to find here on this math problem. So the wall thickness, which would be, this is a plan view looking down on the silo. So we're looking at the wall in the solid lines, and we're looking at the outline of the footing in the dashed lines. This would be a section elevation here. So there's your wall, there's your footing. Here we have the slab. And we have some dimensions here. So the wall thickness 300, the wall height 2.7 meters. Footing width this way will be 900 millimeters, and then the footing thickness here we have 400 millimeters. Floor thickness or slab thickness is 200 millimeters. We are also given the diameter from outside of wall to outside of wall, 6.75 meters. So those are our givens. Now let's begin finding what we need to calculate the volume. We have to begin with a center line length of the wall. So we're going to take our diameter of our outside of wall to outside of wall dimension, and we're going to subtract half of the thickness of the wall off of each side, and that'll take us to the center of the circle here. And if we look here, I've done the math for you. There's your outside of wall dimension, and then here's the formula. Half a wall thickness is 0.15 meters or 150 millimeters. I know I jump interchangeably between meters and millimeters, and I hope you're able to do the same. You'll have to be able to do that to get through this math. We get 6.75 meters minus the half wall thickness, and the half wall thickness takes us to 6.45 meters. Okay, that is our diameter of the circle to the inside, to the dead center of wall. Okay, now we use our formula. This is also a formula that should be second nature to you to find the circumference of a circle. Pi times the diameter, or pi d. So we're going to take this length we just got, put that into our formula, and we're going to discover that the circumference of our center line, or what we can call our center line perimeter, is 20.263. So we've answered the first question on here. With that, we can plug that into our typical formula for finding volume, length times width times height, to find the volume of the wall and the volume of the footing based on what we're given over here. And I've done that here for you. Volume of the wall, there's your symbol for the center line perimeter, C with the L through it, times the width or thickness of the wall times height. And there we have our wall volume of concrete in meters cubed. We do the same for footing, center line perimeter times the width of the footing times the height, which is the thickness of the footing, and we get 7.295. So we've answered these three questions. Next question being asked of us is the area of the slab. So the area of the slab is taken to the inside of the wall. So it would be the area of the circle to the inside of the wall here. Remember, these dashed lines are the footing, right? The footing here lies underneath the slab. So we need to come to the inside of the wall. So calculating the area of the slab, we're going to use a new formula for the area of a circle. Let's down to the answers here. Find the volume of the slab. Yeah, this is basically what I was just talking about. We need the surface area, and then we're going to multiply that surface area by the thickness of the slab to give us that three-dimensional answer. Here's the formula: pi times the radius squared, another formula you need to be familiar with. Pi r squared. Here we have the circle. I've already taken the diameter of the circle to the inside of the walls, so that would have been at 6.75 minus a full thickness of the wall off each side this time to take us to the inside of the walls. Now that we have the diameter, we need to know that the radius of a circle is half the diameter, and that's what I've done here. So 3.075 meters will be the radius of this circle. With that, we can plug that into our formula to find area. Here we go, and we find that the surface area of our slab is 29.706 meters squared. Okay. Now that we have the area, and I think that's being asked of us here, the next question is the volume of the slab, and we just take that area and multiply it by the slab thickness or floor thickness, and that's what I've done here. Using the area of the inside of the walls, the slab volume is that area we found times the thickness. There's your volume of concrete for the slab. Now we have a few more questions, and it's really the way these questions are set up is to get you very familiar with calculating the perimeters and areas and visualizing what's going on in the question. So the next question asks the capacity of the silo. So if you can visualize the silo as a cup or a container, the inside would be the capacity, how much it can hold, which would be based on that area at the bottom. And this time we're going to multiply it by the height of the walls. And that'll tell us the capacity of that silo in cubic meters. So here I've done that calculation. 2.7 meters is the height of the walls. Here is our capacity of the silo in cubic meters, 80.206. Okay, the question does ask us what the capacity would be in liters. I had to look that one up just as a refresher. And we find that 1 cubic meter is equal to 1,000 liters. Okay, and here you have that very familiar ratio and proportioning going on to give you a good visual of how we do the math on this. I put that into fraction form. I put the cubic meters at the same side of the fraction, cross multiply, divide. It's really just 80.206 times 1,000. And we get 80,206 liters, the capacity of the silo. What else is being asked of us in this question? Let's have a look. Next question is the circumference of the inside wall. So circumference would be this distance here on the inside. So it's just the diameter of the inside circle multiplied by pi. Gives us that circumference. And the calculation is done out for you down here. Circumference of the outside of the wall, pi d. There I've taken the measurement. Sorry, that's the outside. Let's go to the inside. Inside first. 6.15 would be the inside of wall diameter multiplied by pi. Gives us a circumference of 19.321 meters. Now we punch that into our answers up here. Next question, so we need this to get the next question. Number of full 1200 millimeter panels on the inside. So if we're doing a formwork on this, and we're using 1200 mil panels, which is a 4-foot panel, how many of these panels are we going to need? I guess is the question. And we're going to, at this point, we're going to disregard the wall height, because we don't actually have the length of our panels, we just have the width. So we're going to multiply that circumference on the inside, or so we're going to divide the circumference on the inside by 1200 millimeters to figure out how many of those panels are going to be needed for the formwork on the inside there. And I've done that here for you. Number of 1200 mil wall panels on inside. 16.101. So the number of full panels, which is what's the question, will be 16. And then the next question up above is, what is the size of the filler panel? And that would just be the portion left over multiplied by the number of millimeters, or the size of each panel. And that tells us that that last panel is 121 millimeters. The next question on here, it just asks for outside circumference. It's basically a repeat of this, but on the outside of the wall. So let's see here. Circumference of the outside of the wall will be that outside diameter multiplied by pi gives us this. Panels the same size, divide by the panel size, we get 17.627 panels, 17 full, and then the 0.672 multiplied by 1200 mil gives us the size of that last panel. So that is your walkthrough on how to calculate the volume for a circular silo, volume of concrete for a circular silo, the wall, the footing, the slab, and also how to calculate how many panels you would need given a specific size. So